Hello everyone, I'm Praveen. Starting from this video, I'll be beginning a brand new lecture series on some questions and topics which are relevantly asked in most of the technical interviews of different top tech companies. So these are mainly interview specific, and as mentioned in the title of this video, we would be covering how to implement two stacks in an array. Initially, we'll look on to the algorithm, how it is actually implemented conceptually, and once we are done with that, we'll actually code it out in a online compiler. So we'll be implementing it in C++. So initially, we'll look on to how it is actually how it actually works in the conceptual way. So there is nothing much to worry about stacks. Stacks, as the name state, is nothing different from the real life. So you can imagine a stack of any data, anything that you can possibly, a stack of plates, a stack of books, is similar to a stack that you actually implement in any coding algorithm or any programming language. So a stack looks like this. If it was a stack of plates, then there will be one plate in the bottom and the plate on top of it and plates stacked on top of that. So what is special about this data structure is that you can only remove or add items to the top of the stack. So if you wanted to remove this plate at the bottom of the stack, you will have to remove all the plates on top of the stack. Similarly, you cannot add a plate on top of the bottom uh, of the plate on bottom of the stack, because it is on bottom of the stack. There are other plates on top of it. So unless you remove the plates on top of the stack, you can't add more plates on top of that. Similarly, in coding programming languages, stack can be of any data type. Like it can be a stack of strings, stack of numbers, or stack of any other possible data type, stack of pair. And C++ stack can be of any type. That depends on whatever you choose to make it a stack of. Let's say you want to add 1 to the stack, and let's say if it was a stack of integers, then you can add 1 to the stack. Then you want it to add 2, then 2 will be added to the stack, and you'll have a pointer pointing to the top of the stack to always keep track of it. This would be top. And you can add more elements to the stack, but what you should keep in mind is that the operations push and pop will only happen in the top of the stack. So pushing means adding an element into the stack, and popping means removing an element from the stack. I believe you're already familiar with this concept if you search for this video. So yeah, I'll just give you the basic idea on how to implement that, and then we'll implement a coding platform. So here you can think about a scenario. So we want to implement two stacks in a single array. So let's consider an array of size 10. So in that array we are implementing two different stacks. So one simple idea that might come to your mind is that to divide the array in two equal halves, and one section can be one stack and the other section can be other stack. So let's say this is of size 5, and we are dividing the array into two different sections, size 5. So we have two sections, one is of size 5 and the other one is also of size 5. So if we divide into equal size and allocate that size for one of the stack and the other size for the other stack, it would work. But would it be efficient? That is a question. It won't be as efficient as, if you tweak it a little bit, you can implement a little more efficient manner. I'll tell you why. Let's say we are adding elements from 1 to 5 to the first section of the stack, which is from here to here. So you allocated the indexes 0 to 4 for the first stack and 5 to 9 for the second stack. That is that happens, as you can see in the screen. So that's how it is allocated, and you're adding 5 elements to the first stack: 2, 3, 4 and 5. Now if you want to add another element to the stack, we do have 5 spaces remaining, but we won't be able to add it to the top of the stack, because the problem is because the rest of the space is allocated for the second stack. So if you constantly allocate a certain amount of space for the first stack and certain number of space for the second stack, it won't be very efficient because we have empty space till we are not able to allocate any elements to it. So we can discard that approach. So in this case, generally you would be keeping the top of the stack. There are different ways in which you can keep the top of the stack. Let's say you can keep the top of the first stack over here and top of the second stack over here. So the push and pop operations can only happen at this end, and push and pop operations of the second stack can only happen at this end. So if you do that, the first element of first stack, let's say in this case you want to insert an element which is let's say 6. We'll insert this element and we have 4 more spaces in the second stack, and you already inserted 5 elements on the first stack, and you can't insert any more elements in the first stack because after that you have element 6, and that section is entirely meant for the stack 2. But what you can do is to slightly tweak the way of implementation, is to make sure that the top of the stack kind of coincide, like the stacks would be growing towards opposite directions. That is not away from each other but towards each other. So what I'm trying to say is that instead of implementing it this way, you can actually implement it this way without giving a static size to any of the stacks. So this would be something like this. So this would be top 2, and we are not giving a specific size. So top 1 would be here and top 2 would be here. So if you implement the stack like this, the advantage is that even if there is no element, let's say we inserted 9 elements into the second stack. So even if you do that, if there was 9 elements in the second stack, you can still insert another element and make sure the stack is the array is completely utilized, because it can go to this direction, completely occupy the array at that point. But if you don't want that, let's say you are inserting 10 elements into the first stack, so like we said 1 2 3 4 5 like in the last case, and it can still continue inserting elements because here there are no elements in the second stack. But if there were 5 elements in the second stack, you won't be able to insert any more elements because we have already utilized the entire space of the array. So here there is no space wastage, which would simply mean that this kind of implementation is much more efficient than the initial approach that we discussed. So once you get this idea, like just think about it a little bit. If you didn't get it, just go back and watch it again and think about it. You'll get it. And once you get the approach, we can go into the implementation using C++. And if you're not aware of how to implement stacks in C++, there are different ways to implement it, but I prefer not to use not to make a stack from scratch while you're using C++, because there is already an inbuilt data structure. Until you are asked by the interviewer to create a stack from scratch, you can just then you will have to implement on your own, else you can simply use this stack data structure which is already available. It looks like this: stack, it's a keyword, and after that you can give the data type of the stack which you are going to give, and you can give the variable name for that stack. So the major functions which would be there in the stack are pop, push, and top. So these are basic stack functions. There are more functions to it, but generally they won't be used as much. There is stack.clear function to clear all the elements in the stack. So yeah, we will only be needing these functions. If you want to know more about the other functions, you can look at the Geeks for Geeks page to figure out more about stacks. So what exactly, let's actually get a Geeks for Geeks. So we have practice area in Geeks for Geeks where we can actually implement 2 stacks in an array. They actually implemented a section of the code for us. We just have to implement a certain section of the code in order to complete this function and implement 2 stacks in an array. The advantages of using something like this is because they will automatically give inputs, so we don't have to give inputs on our own. They'll actually give inputs on their own and check if it is actually right, so it will save our time. So in the driver code section, as you can see, uh, there's a class toStacks, and we have a array, and the array is given a size of n. So n is here 100, and we have two tops initialized. So top 1 is initialized to -1, and top 2 is initialized to size. So yeah, we have, so this top 2 and top 1 represent the top 1 of first stack, and top 2 represents the top of the second stack. So what we have to do is how the functions push and pop are actually implemented in the stacks. So that is all we have to implement. The rest of the things are actually taken care of already for us in the driver code section. So all we have to do is to implement how the push and pop functions in both of these stacks work. By using the same concept I was talking about previously, it can be easily implemented. So we have two stacks. Like I said before, in case of the first stack, you should be able to push elements into the stack until you see that you reach the top of the second stack. That is, here we have inserted 5 elements, and let's say from the other side, in the second stack, let's say we have inserted another 1 and another 2. So we have inserted 2 elements. Here we can insert more elements to the stack because there are still empty space. The size of the array is 10, so we can add 6, we can add 7, and we can add 8 as well. Now we can't add an element to the second stack because we already used enough space of the array, so we can't add more elements. If you try to add another element, it will give you stack overflow. So yeah, that is the idea, and similar thing will happen for the second stack as well. So keeping that in mind, let's try to add functions to both of these stacks. Right, I'll put the link of this practice area in the description, or you can simply Google it, it will be there. So we have push 1. So in push 1, so we have two variables, top 1 and top 2, which we will be using to push it into the stack. So our array name is ARR, so keep those in mind. So when we are pushing an element to the stack, we initially have to check if top 1 plus 1 equals top 2. If this is actually true, then it would mean that if you try to push an element, it will be a stack overflow. So if it is not equal, then we can push an element to the stack. Not equal to top 2, then we can array of so top 1. So when you're pushing an element, initially you increment the top pointer and then push the element. So our element that is to be pushed is x, so we can push that element into the stack. So here initially we increment the top and then we push the element, because top is pointing to the topmost element, so we can't push over there, else it will override that element. And in case of push 2, we'll do the similar thing. Right, top 1 plus top 2 is not equal to, so here we are looking from the top to end, we check to see if top 1 is right before that, and here we push, instead of incrementing, because it is growing in the other direction, we'll have to subtract, decrement it first and then push the element into the stack. So in case of popping from the first stack, we can simply pop the element and we'll have to save it, right? We can save it in an element, so we'll have to return an integer value while popping, so we can save the element on the top of the first stack, so that will be array of top 1, and you can subtract it. So this would be post decrement. Initially the element on the top of the first stack will be stored to x, and after that top one will be decremented, and you can return x. Similar thing would happen in the second case as well, which is top 2. So here top 2 would increment instead of decrementing because it is growing in the other direction. And yeah, that is it. That is pretty much it. So let's see if it works. So right, okay, so if the stack is actually empty, we are supposed to return -1. uh, so they actually are saying that, okay, if no integer is present in the array, then return -1. Okay, so we'll have to give additional check for that. That is, if uh, top 1 equal to -1, then return -1, and equal to n, then you can also return -1. Yeah, this should work. We'll see. This should work, unless, okay, top 2 equal to n. So right, n was not declared in the scope, so yeah, we don't have an n here. That is the size instead of n. Okay, so the variable name is size. Right, that is giving us the right output, and let's submit it. And yeah, we got it accepted, and there we go. 2 stacks in an array. Which would this would be the most efficient approach. I don't think there is a more optimized approach, and we'll be continuing with much better, a little more difficult problems from Lead Code, Geeks to Geeks, and other platforms, which is industry relevant and which is asked multiple times in interviews. So if you want me to discuss the specific question, just let me know in the comment section. I'll discuss that question. See you then. Bye. Good night.